Hi folks, we're going to take a look at page 385, number 10a. So what they want us to do is simplify the expression and state any restrictions on the variable. Okay, so here's our expression, and hopefully the first thing you notice is that the base in each of these logarithms is the same. They're both base 10. Okay, and I've got a subtraction of two logarithms. So hopefully that makes you think of our second law of logarithms. So I'm going to apply that here. So this logarithm of the difference, the difference of the logarithms is equivalent to the logarithm of the quotient of the two expressions. So this becomes x squared minus 4 over x minus 2. Okay, and of course I hope you think of factoring that numerator, because some nice stuff will eventually happen. And here we see that we can reduce the x minus 2's from numerator and denominator. Okay, so we're left with logarithm of x plus 2. Okay, so now let's try to determine what the restrictions are. Okay, now first thing is let's recall that yes, I'm left with an x plus 2 here, but originally I had an x minus 2 in the denominator. Okay, so the fact that I've reduced it from the numerator doesn't eliminate the fact that I'm not allowed to accept 2 as a possible input. Okay, so here we have to say that x can't be equal to 2. Okay? But it does go beyond that, because remember, this is a logarithmic expression, and we have to remember that logarithms only accept strictly positive inputs. Okay, so I need x plus 2 to be greater than 0. In other words, x has to be greater than negative 2. But of course, can't be equal to 2. Okay. Now, one might think that that's the end of the story. Okay, and this is a very, very important principle that's going to come into play when we start working a little more with logarithmic expressions and eventually equations that have logarithms in there, is that it's not enough to just satisfy the conditions on the final expression, on the second last step of our work here. Is we also have to satisfy the original expression. Okay? So despite the fact that we did all this nice simplifying, we have to make sure that the original expression is also valid. Okay, and this is where we see we have a problem. Okay, because if we take a look at x squared minus 4, that's the input to that logarithm. Well, what does x squared minus 4 look like? It's negative between negative 2 and 2. Okay. We had said, hey, x can be anything greater than negative 2, but now we realize that all these values between 2 and negative 2 give us negative numbers. So we cannot include them because of that first expression. And in fact, if we look at the second expression, okay, and notice here how, as before, when I'm looking at the sign of a polynomial function, I use a graph to help me out. Okay, nice and quickly. If I look at x minus 2, I see that it's also not valid for anything less than 2. Okay, so again, we see that just looking at our final statement, or even our last two expressions, was not enough. Okay, so what we need here, our restrictions, okay, is that x has to be strictly greater than 2. Okay, because anything less than 2 will make both of the two original expressions not exist, and of course when it's equal to 2, these won't exist either. Okay, so big lesson here is that when you're simplifying a logarithmic expression, the same way as when you're simplifying a rational expression, you have to make sure that you consider the original expression when determining your restrictions. Okay, that's it for this one.